Live from the Baikonur Cosmodrome in Kazakhstan and the ILS Anchor Desk, you are watching coverage of the Proton Breeze M launch of the Eutelsat W2A satellite.
You are looking live at pad 39 at the Baikonur Cosmodrome, Kazakhstan. On the launch pad is the Proton Breeze M rocket with the Eutelsat W2A satellite on board. Final preparations underway right now for liftoff in less than 25 minutes. Hello, I'm Marla Weech, and welcome to the first mission of 2009 for International Launch Services. Today marks a significant milestone for ILS. This is the 50th launch of an ILS commercial Proton to date. Thank you for joining us today for this special launch. Launch is set for 10:24 p.m. Baikonur time here in the Eastern Time Zone of North America and at the ILS Anchor Desk on the East Coast. Launch time is set for 12:24 in the afternoon. Our customer, Eutelsat, and the satellite builder, Thales Alenia, are both located in France, where launch time is set for 6:24 in the evening. Joining me in the studio is Michael Thie, ILS Program Director. This is Michael's first launch broadcast here at the Anchor Desk, but not his first launch campaign by any means. Michael has been with ILS for 3 years and has managed 4 launch campaigns with 2 more new campaigns on his schedule in the next 5 months. Going to be busy. During the broadcast, Michael and I will be monitoring pre-launch activities. Michael will be providing mission and insight update into what's going on at the launch site. Now, Michael, what can you tell us about today's mission?
Well, thanks very much, Marla. The mission today is to carry the satellite into space is a fairly standard one. The Proton rocket is a 3-stage booster with a 4-stage, the upper stage, known as the Breeze M. It will be a little more than 9 hours from liftoff to satellite separation, including 5 burns of the Breeze M upper stage. About a minute after liftoff, the Proton booster will be traveling at greater than Mach 1.5, experiencing maximum dynamic pressure, or what we engineers call max Q. Simply put, this is the point at which the aerodynamic stress on the satellite is maximized. At 2 minutes into the flight, stage 1 separation occurs. Depending on the weather conditions, we should actually be able to witness stage 1 separation. Stage 2 separation happens almost 5.5 minutes into flight. Stage 3 separation occurs 9 minutes and 35 seconds into the flight, and then the Breeze M is on its own to carry out the rest of the mission. The Breeze M engine will ignite a total of 5 times to carry the satellite increasingly higher while lowering the inclination, finally releasing it into a geosynchronous transfer orbit.
We plan to follow the Proton's progress through conclusion of the first burn of the Breeze M upper stage. That burn is scheduled to be completed nearly 16 minutes into flight. A few minutes after that, the vehicle is scheduled to pass out of range of a receiving station for about 50 minutes. And because we won't be receiving any updates for about an hour, we will conclude our broadcast at that point. Now, we encourage you to check the ILS website, which is www.ilslaunch.com, for updates on the progress of the mission throughout the day. Updates are posted as soon as they come in.
And we're at T-minus 10. T-minus 5, 4, 3, 2, 1. And we have liftoff of an ILS Proton rocket from the Baikonur Cosmodrome in Kazakhstan, carrying the W2A communications satellite.
Flight status nominal.
So far, the status is nominal. The spacecraft is traveling in the easterly direction.
Engine combustion chamber pressure is within specified limits.
About 10 seconds after liftoff, the rocket did a roll maneuver and will soon experience maximum dynamic pressure, or max Q. It corresponds to about Mach 1.5 and occurs about 62 seconds after liftoff.
40 seconds. Flight status nominal.
We're at plus 45 seconds, and status is nominal. Everything seems to be proceeding as the vehicle heads easterly with a flight
Launch vehicle
azimuth of about 71.9 degrees. We're at 62 seconds and max Q.
Position looks good.
We'll be coming up shortly on first stage separation from the second stage, and we're fortunate we're going to be able to see it with the clear evening.
80 seconds. Launch vehicle operation is stable.
Everything is nominal. All systems are stable.
90 seconds. Stage
We're 90 seconds into the launch and still a clear view. And in approximately 109,
mission is proceeding normally.
1 minute and 59 seconds, we should be able to see first and second stage separation.
110 seconds. Information
1 minute 55. Everything is nominal. And there's second stage separation.
120 seconds. We have second stage engine ignition.
We have confirmation of first and second stage separation. The second stage engines actually ignite while still attached to the first stage, and the exhaust from these engines escape through the open grid work between the two stages.
Combustion chamber pressure looks good. 150 seconds. Stabilization is steady.
And it looks like we have a signal ignition on all 4 second stage engines.
160 seconds.
All is nominal.
Continues to proceed.
And the next milestone will be separation, or stage 2-3 separation, which will occur at plus 5 minutes and 29 seconds.